Lesson 2.4 covers logic proofs. A logic proof is the process in which we start with one or more hypotheses, which are assumptions or premises, and we work our way towards a conclusion. For a proper proof, each step of the proof must follow the laws of logic. In mathematics, a statement is not accepted as valid or correct unless it's accompanied by a proof. In many of your advanced math classes, you'll do proofs. You're probably most familiar with your geometry proofs. In high school, in a geometry class, you would be given a theorem, and that theorem wasn't considered valid until it was proven. So you had several chapters that would focus on proving theorems. Well, this is true with many theorems in many math classes. And we do this also with logic proofs. A warning with these, you cannot just talk your way through these proofs. In this class, if I give you a set of premises and tell you to prove a certain statement, you can't just talk your way through it and say it makes sense. You have to set up these proofs properly using the correct mathematical symbols and backing them up with the laws of logic, which we're going to introduce in this section. So let's look at those tools that we're going to use to perform the logic proofs. As I mentioned, in a logic proof, every statement you make has to be backed with a definition or a law. You have to prove what you're stating is true and give a reason why it's true. You basically have to tell the grader what your proof is for every statement you make. And this is often the hardest part about the logic proofs. It becomes easier when you focus on the tools you have to perform these proofs. So let's look at those different tools, and these tools are something you're going to need to learn. Your first tool are all the basic definitions of the connectives. Those can be used as your proof for a reason. So basically, you need to know when each connective, which is the and, the or, the not, the biconditional, the implication, you need to know when each of these are true and when they're false. For example, the and connective was only true when both propositions were true. And we know this by the definitions we were given for these connectives. When giving the reason for these, you simply make the statement by definition of and state the connective that you're using. So for example, we might say by definition of or, if we were using the or connective. If we were using the negation or the not connective, we would simply say by definition of the negation. In addition to all the definitions of the connectives, we also have the definition of the contrapositive that we can use as a reason. You know from a previous lesson that if we have the implication P implies Q, then its contrapositive is not Q implies not P. For the contrapositive, the order is switched and we take the negation of each part. Recall that the truth table for P implies Q, the implication, and the truth table for its contrapositive were the same. So if P implies Q and its contrapositive are the same, they're logically equivalent. This basically means that if P implies Q is true, we know its contrapositive is also true. If P implies Q is false, then we can conclude that its contrapositive will be false. This wasn't the case with the converse or the inverse. So we cannot use the definition of converse and inverse in our logic proofs. This was only true for the contrapositive. For simplicity, we're going to refer to all of this information as definition of the contrapositive. That's going to be our reason in the proof. Now let's look at a new law. We're going to use the law of detachment. The law of detachment states that if P implies Q is true, and if P is true, if the implication is true, and if the hypothesis, if the first part is true, then we know that Q must also be true. To help us see this, let's look at the truth table. We'll begin with the implication. It was true in 3 cases, in the line 1, line 3, and line 4. But P had to also be true. The only time that both the implication P implies Q was true and P was true was in line 1. And we can see in this line Q was also true. So if we can show that the implication and the hypothesis are both true, then the law of detachment tells us that the conclusion that Q is also true. Let's look at an example for this. Assume the following to be true. If I complete the quiz a day early, I will get a 5-point bonus. I completed the quiz a day early. We're going to break down each sentence into logic symbols. So we're going to let P be the statement, I complete the quiz a day early. We'll let Q be, I will get a 5-point bonus. And you'll learn when we do the logic proofs that you let the first statement you're given be P, let the second statement you're given be Q. If you're given a third statement, it would be R. But you list these in the order they're given. So I let P be, I completed the quiz a day early because that was the first statement that I was given. I let Q be, I will get a 5-point bonus because that was the second statement I was given. When you're giving these basic premises, you leave out the words such as if and nots and ands and thens. Now we can rewrite each statement in symbols. So if I complete the quiz early, I will get a 5-point bonus. This is an if-then statement. The hypothesis was a P and the conclusion was a Q. So I have P implies Q. My second sentence was I completed the quiz a day early. This was my P. Well, we were told that both of these were true. So we see that we have the following, P implies Q and P, and we were told they were both true. Since we were told both of these were true, the law of detachment lets us know that the Q is also true. So basically we can conclude that Q is true and Q was I will get the 5-point bonus. Let's look at another example. Assume the following to be true. If the weather is nice, I will leave work early, and the weather is nice. So I have 2 basic statements. I'm told that the weather is nice, and I'm told I will leave work early. Let the first one be P, and let the second one be Q. So we're going to let P be the weather is nice, and we're going to let Q be I will leave work early. Now we take each of our sentences and translate them into symbols. So the first sentence is, if the weather is nice, I will leave work early. This is P implies Q. The second sentence is, the weather is nice. That was our P. We're told these are both true, so we can conclude that Q is also true, and our reason is the law of detachment. So basically we can conclude that I will leave work early, which is my Q. The next law we're going to look at is another new law. It's the law of syllogism. The law of syllogism basically states that if P implies Q and Q implies R are both true, then P implies R must also be true. This law is very similar to the transitive property you learned in an algebra course. The transitive property basically states that if A equals B and if B equals C, then A equals C. The transitive property also applies to inequalities. If A is less than B and if B is less than C, then A has to be less than C. Let's look at this with an example. I know 5 is less than 10, and I know 10 is less than 20. If I drop the 10 out of the middle and take the two numbers on the end, I get 5 is less than 20, and that's also true. So we can use the transitive property to help us remember the law of syllogism. And I like to think of this law and the transitive property as skipping the middleman. Just like I dropped the tens from the inequalities, I'm going to do the same thing with this law. If P implies Q and if Q implies R are both true, notice that the Q in the middle has been repeated. It's the conclusion for the first implication, and it's the hypothesis for the second implication. If I drop it and put the P and the R together, then I get P implies R, and that's also true. So that middle part is going to get left out, and we're left with the P implies R. So let's look at an example. Assume the following to be true. If I get a speeding ticket, I will get points added to my driving record. If I get any more points added to my driving record, my insurance company will cancel my policy. So I have three basic statements. The first one is, I will get a speeding ticket. Remember, leave out the word if. The second is, I will get points added to my driving record. That's going to be our Q. The third statement dealt with the insurance company canceling your policy. So we'll let R be, my insurance company will cancel my policy. Always list these in the order they're given. Now we can rewrite each statement in symbols. So begin with the first sentence. If I get a speeding ticket, I will get points added to my driving record. Getting a speeding ticket was our P. Getting points added to our driving record was our Q. So this is P implies Q. Next, if I get any more points added to my driving record, my insurance company will cancel the policy. Getting the points added to the driving record was our Q. The insurance company canceling the policy was our R, so this is Q implies R. We see that we have the following. We know that these are true because we were told they're true. P implies Q and Q implies R are both true. So I can apply the law of syllogism and drop out the Q's, and I'm left with P implies R. Based on the law of syllogism, I know that this is true also. So I can make the following conclusion. Since P was having points added to the driving record, and R was the insurance company canceling the policy, I can conclude that it's true. If I get more points added to my driving record, my insurance company will cancel my policy. Now that we've looked at the tools that we're using, and remember the tools are the definitions for our connectives, we've got the definition of the contrapositive, and then we have two new laws. We have the law of detachment and the law of syllogism. We're going to look at using those to set up our logic proof. Now, some teachers and some books are very strict on how they want the proof organized, while other books and teachers are not organized at all. I've found that the more structured you are, the less likely you are to leave out a step. And since this is an online class, we have the added hassle of online grading. So we've got to have some consistency there. These proofs have many steps, and on the quizzes and tests for this module, I'm going to break down each problem into several parts and test you on each part. So what we're going to do in the next few pages is go over the setup that you're going to be tested over. Step 1 is to assign variables to the propositions that relate to the individual statements made in the premises. So in the previous example, each sentence is a statement that's made. It's a premise. Sometimes those premises had one statement in them, and sometimes they were compounded. For example, if I get a speeding ticket, I will get points added to my driving record. That had two individual statements. We pulled out each statement and let one be a P and the other be a Q. That's our first step for all of these logic proofs. These premises might contain compound propositions or negations. We always want to pull out the basic statements used in the premises. And the first thing that I will quiz or test you over will be listing these basic propositions. Sometimes the premises are positive and sometimes they're negative. Sometimes they'll have the word not in there and sometimes they will not. For example, if I say it is raining, that's positive because it does not contain the word or a form of the word not. Likewise, if I say it is not sunny outside, that would be negative because it does contain the word not. Even if a premise is negative, I always want the basic proposition to be positive. And the main reason to do this is just to make things simpler. If we see a P, we're going to know it's a positive statement. Whereas if we see a not P, we're going to know it's a negative statement. And for class consistency, assign the variables in the same order the propositions were listed. Now, step 2, we're going to list the premises or the truths using logic symbols. Once you pull out those basic propositions, we're going to change them to logic symbols. We simply make a list of all the premises in the form of logic symbols using the P's, the Q's, and the R's. If there are any implications, the if-thens, I also list the contrapositive since I know it will be true. This just helps us. I may or may not need it, but since I know it's true, I list it just in case it helps me. Step 3, we're going to list the conclusion using logic symbols. So you basically want to know what you're trying to prove, and we want to know what it looks like in logic symbols. And I generally do these two steps together. I do steps 2 and 3 at the same time. Step 4 is follow through with the direct proof. This is the hardest part of the proof. This is the part where you have to work through the premises and give a reason for each step. And you do this until you've proven the conclusion, until you reach that conclusion that you're trying to prove. This is the main part of the proof. The majority of the points for these questions is going to be in step 4. Well, there's two types of logic proofs. There's a direct proof and an indirect proof. With a direct proof, you begin with the premises and work your way to the conclusion. With an indirect proof, you take what you're trying to prove and begin by assuming that it's false. So you basically take something you're trying to prove true and you assume that it's false. As you work through the proof, at some point you're going to reach a contradiction. This just means that your assumption that that statement was false is not correct. And if it's not false, then it has to be true. In this class, we're just going to focus on direct proofs. And as I mentioned before, I found that it's easy to leave out a reason for your conclusion if you're not organized. When you complete a proof for this class, I want you to follow the basic setup, and this is going to help you from leaving out steps. Every sentence in your proof is basically going to need 3 parts. You're going to have an if or a since statement. It's just a sentence that's either going to start with if or since. In this part of the sentence, you usually are drawing upon what you're given as a true statement or something you have just proven to be true. And as I said, these are usually always a true statement. Then you're going to follow that with a then statement. This is basically the conclusion that you're proving in that particular line. And finally, you have to give a reason. You're going to end it with a because or a by statement. And this is basically your proof or your reason for what you just stated. And this is the part where you're going to use the tools from the previous pages of these handouts. So let's look at a few examples. And these aren't full proofs, these are just step 4 that we're looking at. So an example of a line from step 4, a line from our proof, we may say, if P is true, then not P is false by definition of the negation. Let's look at our 3 parts. The if part I achieved by saying if P is true. I've simply stated a true statement. The purpose is to remind the reader of this statement because I'm about to use this fact. Next is my then. I have then not P is false. This is the conclusion that I've just made based on my if statement. So I give an if statement that's true. I make a conclusion based on that statement. And then my third part is my reason. That's the by definition of the negation. This is the proof I'm using to justify my conclusion. Let's look at another example. If P implies not Q is true, then Q implies not P is true by definition of the contrapositive. This sentence has 3 parts. I've got my if statement, I've got my then statement, and I've got my by statement. My if is what I was told was true. P implies not Q is true. My then is what I'm concluding. I'm concluding that Q implies not P is true. And then I have to give a reason. My justification or my reason for concluding this is by the definition of the contrapositive. My proof is going to consist of several lines of these 3-part statements until I reach my conclusion for the entire proof. And finally, step 5, I finish out the proof by stating what I've just proven in a complete sentence. For the main portion of these proofs, we're going to use logic symbols instead of writing out all the long sentences. But in the final step, we're going to restate that conclusion without symbols. So let's look at some examples of direct proofs. As I go through these examples, I'm going to list the 5 steps just to help you learn what 5 steps are involved. So our first example, suppose that it is true that if Dan is happy, so is Bill, and if Sandy is not happy, then Bill is not happy. And I want to show that if Dan is happy, then Sandy is happy. This proof may seem quite wordy at first. That's why step 1 is to break it down into our basic propositions. So you take these and you list them in order using no compounds, no if-thens, and you make sure they're all positive. So if I read through, it says, suppose that it's true that if Dan is happy. So the first thing I'm told is Dan is happy. I'm going to let that be my P. The next statement I come to is so is Bill. So even though it says so is Bill, well, Bill is what? He's also happy. So I'm going to write Bill is happy. Instead of writing so is Bill, I need to give that more meaning and write Bill is happy. The next one I come to that's different is Sandy is not happy. Now remember, I want my basic propositions to be positive, so I'm going to leave out the not, and I'm going to let R be Sandy is happy. The next thing I come to is Bill is not happy. Well, I already have a statement that Bill is happy, so I don't need to worry about that one. In my show that, I've got Dan is happy. I already have that one listed. And Sandy is happy, and I already have that one listed. So I only have 3 basic propositions. Next, I want to set up a table that lists my truths. So basically, the first couple of sentences in that proof I'm told are true. So the first thing I'm told is true is if Dan is happy, so is Bill. And the second thing I'm told that's true is if Sandy is not happy, then Bill is not happy. So using the P, Q, and R that we just listed, Dan is happy is our P, Bill is happy is our Q. So I have an if P, then Q. So I have P implies Q. Now, as I mentioned before, if I'm given an implication, I'm going to automatically write the contrapositive. Because if this implication is true, its contrapositive is also true. So if P implies Q is true, then I know not Q implies not P is also true. Next, I'm told this statement is true. If Sandy is not happy, then Bill is not happy. Well, Sandy being happy was my R, so Sandy not happy is not R. Bill being happy was my Q, so Bill not being happy is not Q. So I have if not R, then not Q. So this is not R implies not Q. I'm told that this is true. Since I'm told this is true, let me automatically list the contrapositive, which would also be true. So I switch the order and negate each side, and I get Q implies R is true. Next, we want to state what we're trying to prove. I'm trying to prove if Dan is happy, then Sandy is happy. Dan being happy is P, Sandy being happy is R, so this is P implies R. I want to show that this is true. So now step 4 is the guts of my proof. It's the most important part of the proof. You've got to look at your table and say, how can I use this information to prove P implies R is true? When I see a lot of implications, I think of 2 things. I saw implications in the law of detachment, and I saw implications in the law of syllogism. Look at what you're wanting to prove. You're wanting to prove P implies R. In my table, I have a P implies Q, and I have a Q implies R. So if I use these 2, I can apply my law of syllogism. So if P implies Q and Q implies R, I can leave out the Q and end up with P implies R. So I'm not going to use the first contrapositive that I listed, but I am going to use the second one. So if I think of the order for this proof, Since I'm going to use the Q implies R, I have to prove how I knew that was true. So I'm going to need a line in my proof for that. And then I'll need a line in my proof applying the law of syllogism to get my conclusion. So let's look at step 4. And remember, every line in my proof has to have the 3 parts: the if, then, and the because. So first, I want to be able to use the Q implies R, so I have to prove that. So I'm told that not R implies not Q was true. So I begin with my if. If this was true, and I know it was true because I was given that, I was told that. Well, if that's true, then the contrapositive Q implies R is also true. By, my reason for this is the definition of the contrapositive. So this is the first line of step 4. If not R implies not Q is true, then Q implies R is true by the definition of the contrapositive. Now that I've proven Q implies R is true, I can use it with my law of syllogism. So my next step is, if P implies Q is true, I know that's true because I was told that, I was given that. And if Q implies R is true, I know that's true because I just proved it with my first line. Well, if both of these implications are true, then leave out the Q and I get P implies R is true. My reason for doing this is the law of syllogism. So I have my if, I have my then, and I have my reason, my by. So if P implies Q is true, and if Q implies R is true, then P implies R is also true by the law of syllogism. Since I wanted to prove P implies R was true, this second line did that, so I know I'm through with my proof. So step 5 is just end with a complete sentence. What does P imply R mean? Well, P was Dan is happy, and R is Sandy is happy, so I can conclude that if Dan is happy, then Sandy is happy. Let's look at our next example. Suppose that it is true that either John obeyed the law or John was punished, but not both. And also suppose it's true that John was not punished. I want to prove that John obeyed the law. So step 1, we're going to go through this proof and list our basic propositions. So as I'm reading through this, it says, suppose it's true that either John obeyed the law. So the first basic statement I'm told is John obeyed the law. I'm going to let that be my P. The second thing I'm told is John was punished. So I'm going to let Q be my John was punished. Then I have John was not punished. Well, since I already have a John was punished, I can skip that one. And then I want to prove John obeyed the law. I've already mentioned John obeyed the law, so I only have a P and a Q in this one. This one does not have an R. Step 2 is list your truths. So go to the sentences from the example. I was told that it was true that either John obeyed the law or John was punished, but not both. And also I was told that it was true John was not punished. So let's look at the first one. John obeying the law was our P. John being punished was our Q. These are connected with an or, but it says not both, so this is the exclusive or. So I'm going to have P or Q, but I've got the exclusive or. Next, John was not punished. Well, John being punished was my Q, so John not punished is my not Q. Now, if you notice, this table doesn't have any contrapositives. It doesn't have the column for contrapositives because I didn't have any implications. I didn't have any if-then statements. Now let's look at what we're trying to prove. We're trying to prove John obeyed the law. John obeying the law was our P, so we're trying to prove that P is true. So now you've got to look at what you're trying to prove and look at what you're given as true and organize your proof. So I just like to think through it first. The only things I'm told are true are P or Q and not Q. Well, let's start with the negation. If not Q is true, then I know Q is false. So we're just going to keep that in the back of our mind because we may use that as one of the lines in our proof. I'm also told P or Q is true. And with the exclusive or, think back to your truth tables to find out when this is true. This was only true when either P or Q were true, but not both. So either P is true or Q is true, but they're not both true. So I'm wanting to prove P is true. I want P to be true. So with the exclusive or, that means that Q needs to be false. Well, we discussed earlier, if not Q is true, then Q is false. So I'm going to reverse this logic, and that's going to be my proof. I'm going to start out with the fact that not Q is true and conclude that Q is false. Then I'm going to use the fact that Q is false and that this or statement is true to prove that P is true. So let's look at the steps of our proof. So first we said, if not Q is true, then Q is false. And the reason is the definition of the negation. This has my three parts. I have my if, I have my then, and I have my by. My if was something I was told was true. My then is what I'm trying to prove in this line. And my by is the reason. If not Q is true, then Q is false because they're negations of each other. So my reason is definition of the negation. Now that I've proven Q is false, I'm free to use it in my proof. So let's look at the next line. We're going to begin with our or statement, and let's just remind the reader or remind the grader what that means. If P or Q is true, then either P is true or Q is true, but not both. And our reason is definition of exclusive or. So I have my three parts. If P or Q is true, then either P or Q are true, but not both, and by, or because, the definition of the exclusive or. So now I've taken something that I was told was true, and I've drawn a conclusion. So now I know either P is true or Q is true. I can use this later in my proof if I need to. I am going to use that in my next line. Well, since Q was false, which I concluded in the first line of my proof, then P must be true by definition of exclusive or. So I was told that either P or Q have to be true by this definition. Well, since Q is not true, then that means P must be true. So since Q is false, that serves as my if. Since Q is false, then P must be true. That's what I'm concluding in this line. And my reason was, again, the definition of the exclusive OR. When you use the definition of OR, you're always going to have two lines in your proof. The first one is just stating that the P or the Q must be true. The second one is showing which one of those is true based on the other information in your proof. Now, I was trying to prove that P was true, and I have that in my proof. So I've completed step 4. I've shown what I needed to show. So now step 5 is end with a complete sentence. I know that P was true. P was the statement, John obeyed the law, so I can conclude John obeyed the law. Let's look at our next example. Suppose that it is true that it is snowing, and that if it is warm, it is not snowing, and if it is not warm, I cannot go swimming. I want to prove I cannot go swimming. So let's begin with step 1. I want to break this problem down into basic propositions. So first, look at what I'm told. It's true that it is snowing. So the first statement I come across is it is snowing. That's going to be my P. Next, I'm told that it is warm. So I'm going to let that be my Q. The next statement is it is not snowing. Well, if I leave out the not, I have it is snowing, and I've already listed that as my P. Next, I have it is not warm. Well, if I leave out the not, I have it is warm, and that's my Q. Next, I come to I cannot go swimming. Leave out the not, and I have I can go swimming. I don't have that listed, so I need an R that's I can go swimming. And then I want to prove I cannot go swimming. Well, if I leave out the not, that's I can go swimming, and I already have that listed. So I have 3 basic propositions. Step 2, let's list our proofs. So take the 3 statements that we were told were true, and I'm just list them in a table to make it easier. First, I'm told it is snowing. That was my P. That's not an implication, so it's not going to have a contrapositive. So I'm not going to have anything in this cell of my table. Next, I have, if it is warm, then it is not snowing. Well, being warm was my Q. Snowing was my P, so not snowing is not P. So I have Q implies not P. Since this is an implication, I want to list the contrapositive. So switch the order and change the sign, and I have P implies not Q. Then finally I'm told if it is not warm, then I cannot go swimming. Well, being warm was Q, so not warm is not Q. Going swimming was R, so not going swimming is not R. So I have not Q implies not R. And again, I want to list the contrapositive because I may or may not need it in my proof. So for the contrapositive, switch the order and negate each side. So I have R implies Q. Next, we look at what we're trying to prove. I'm trying to prove I cannot go swimming. Well, R is that I can go swimming, So I'm trying to prove not are. And I want to show that this is true. So now keep in mind what you're trying to prove is true. I want to end with a not are. So if I look back through my table, the only not are I have is right here. The not Q implies not are. So I know I'm going to need this in my logic proof. Knowing that alone isn't going to prove that not are is true. So look at what else we're given. Here I have a not Q, and in this contrapositive I have a not Q. So I could put these together with the law of syllogism, and I could end up with P implies not are being true. Well, if I have P implies not are, if I know that's true, and since I know P is true, I can use the law of detachment to prove that the conclusion, the not are, is true. So I'm going to end up using the P, I'm going to use this contrapositive, and I'm going to use this implication with the law of syllogism. So step 4, let's follow through with the proof. Now that we've got the basic idea of how we're going to prove this, let's make sure each line has the 3 parts. So first, we've got to prove the contrapositive that we had listed. If I look back at the table, I had that contrapositive listed, but it wasn't given to me in the proof. It wasn't given to me as a truth. So I have to first prove that it was true. So I can prove that it's true by using the implication that I was given. So I was told Q implies not P is true. Since I'm told that's true, I can conclude that P implies not Q is true because it was the contrapositive. So my reason is definition of the contrapositive. So my first line is, if Q implies not P is true, then P implies not Q is true by definition of the contrapositive. Since I've now proven that P implies not Q is true, I'm free to use it in the next line of my proof. So if P implies not Q is true, and if Q implies not R is true, this was true because I was given it was true. Well, now if I leave out the not Q's, I can have P implies not R is true. I know I can leave out the not Q's because of the law of syllogism. So that's my reason. That's my by statement. So I have if P implies not Q is true, and if Q implies not R is true, then P implies not R is true by the law of syllogism. Now that I've proven P implies not R is true, I'm free to use it in the next line of my proof. So I'm going to use the P implies not R is true, and I was given P is true. Well, if I have an implication and I'm told that the hypothesis is true, I can assume that the conclusion is true. So I can conclude or assume that not R must be true. And the reason for this is the law of detachment. Now I've proven that not R is true, and that was my goal. That was what I was trying to prove. So I'm ready for step 5, end with a complete sentence. R is the statement, I can go swimming. So not R is I cannot go swimming, and I was trying to prove that. So my conclusion is I cannot go swimming. Let's look at the next example. Suppose that it's true that if I am lazy, I do not study, And it's also true that I study or I enjoy myself. It's also true that I do not enjoy myself. I want to prove that I am not lazy. So step one, let's list our propositions. So I begin looking through here, and the first thing I come across is I am lazy. So that's going to be my P. The second basic statement is I do not study. Leave out the not, and I have I do study. That's going to be my Q. Then I have I study. I've already listed that as my Q. Or I enjoy myself. I don't have an I enjoy myself, so that's going to be my R. Then I have I do not enjoy myself. Ignore the not, and I have I do enjoy myself. That was already listed as R. And finally, in my proof, I'm showing that I am not lazy. Leave out the not, and I have I am lazy. That was my P. So I have three basic propositions in this one. Now I was told three statements that were true, so let's list the truths in a table. First, I was told, if I am lazy, I do not study. Being lazy was your P, and studying was your Q. So this is P implies not Q, since it's if I'm lazy, I do not study. Since this is an implication, let's list its contrapositive. So switch the P and the Q and negate each side. So I have Q implies not P. Second, I have I study or I enjoy myself. Well, studying was Q and enjoying yourself was R, so I have Q or R. This is not an implication, so it's not going to have a contrapositive. The next truth I was given is I do not enjoy myself. Well, enjoying myself was R, so I do not enjoy myself was not R. Now step 3, look at what you're trying to prove. You're trying to prove I am not lazy. P was I am lazy, so I'm trying to show not P is true. So now step 4 is the formal proof, the official proof. So let's look at what I'm trying to prove. I'm trying to prove not P is true. So as I look through my proofs, these are the tools that I can use. The only one that has a not P is in the contrapositive. So I'm going to have to begin with my implication and state that because it's true, the contrapositive is true by definition of the contrapositive. I wasn't given the contrapositive, so I'm going to have to spend a line in my proof proving that. That's going to leave me with this being true. Well, when I have a single implication, think to your law of detachment. Since I know this is true, if I can prove Q is true, then I'll be able to prove P is true. I can't just assume the conclusion is true because the implication is true. The only time the conclusion was true and the implication was true was when Q was also true. So look at how can I prove Q is true. Q was involved in an or statement. Well, if this is true, then that means either Q or R must be true. Well, the only way to prove that Q has to be the true one is to show that R is false. Well, look down here. I'm told not R is true. So if not R is true, then R has to be false. So as you're thinking through these proofs, jot down notes And then you're going to take those notes that you just jotted down and basically put them in reverse order, and that's your proof. So I'm going to start with not R being true and conclude that R is false. Since R is false and it's involved in an OR, Q has to be true to make this OR statement true. Well, since Q is true and this implication is true, then I would know not P is true. And just remember, before I can use the contrapositive as true, I've got to prove it's true. So this proof is going to have several steps to it. First, let's say if not R is true, then R is false by definition of the negation. Now we're going to use the OR statement. And anytime you have an OR, it's going to be 2 lines in your proof. First, you just state the definition. If Q or R is true, then Q is true or R is true by definition of OR. Now you prove which one is true. Well, since R was false, Q must be true. And again, we're using the definition of the OR. So at least one of these has to be true. Since R was false, then that means Q must be true by definition of the OR. And anytime you use the OR statement, you're always going to have these 2 lines. Next, I want to use the fact that Q is true and the fact that the contrapositive is true. But before I can use the fact that the contrapositive is true, I have to prove it. It wasn't one of my givens. So start with the implication that you were given. You were given P implies not Q is true. Because this is true, I can conclude that Q implies not P is true. I can conclude that its contrapositive is true by definition of the contrapositive. Since the Q implies not P was not given to me in the problem, I have to prove it. It has to be a line in my proof. Now I can use the fact that Q is true and that this implication is true to conclude that not P is true. So if Q implies not P is true, and if Q is true, then not P must be true by law of the detachment. I was trying to prove not P is true, and I've done that, so I've completed my proof. All that's left is to write my conclusion, and I use this in a complete sentence. P was I am lazy, so not P is I am not lazy. So my conclusion is I am not lazy. Now let's look at our final example. Suppose that it is true that if I enjoy studying, then I will study. Also, I will do my homework or I will not study. And finally, I will not do my homework. I want to show that I do not enjoy studying. Again, we begin by listing our basic propositions. So read through this example, and the first statement that we come to is, I enjoy studying. That's going to be my P. Next, I will study. This is different. Enjoying studying and actually studying are 2 different concepts. So I will study is going to be my Q. Next I have I will do my homework. That hasn't been listed yet, so that's going to be my R. Then I have I will not study. If I leave out the not, I have I will study, and that was my Q. Then I have I will not do my homework. If I leave out the not, that was my R, I will do my homework. And then I want to show that I do not enjoy studying. Leave out the not, and I have I do enjoy studying, and that was my P. So I have three propositions. I have the P, the Q, and the R. Now let's list our truths. Let's list what we were told is true in a table. So first I was told, if I enjoy studying, then I will study. Enjoying studying was my P, and studying was my Q, so this is P implies Q. Since this is an implication, I want to list the contrapositive. The contrapositive, I switch the order and have Q implies P, and then take the negation of each side. So not Q implies not P. The next truth is, I will do my homework or I will not study. Doing your homework was R, and studying was Q, so not studying is not Q. So this is R or not Q. Finally, I will not do my homework. Doing your homework was R, so not doing your homework is not R. Now we look at what we're trying to prove. We're trying to prove I do not enjoy studying. Well, enjoying studying is P, so we're trying to prove not P is also true. So now look back at what you're given and what you're trying to prove. And as you do this, jot down your thoughts so you'll know what order you need to go through. So I'm trying to prove not P is true. The only not P that I have listed is in my contrapositive. So I know I'm going to need my contrapositive. So at some point in my proof, I'm going to have to use the definition of the contrapositive. So if I'm trying to prove this is true, I'm going to use the fact that my contrapositive is true, and that means I need to show that not Q is also true. Well, look at where else not Q occurs. Not Q occurs in my OR statement. So in order to prove not Q is true, I need to prove that R is false. Well, I was told that not R is true, so I can use that to prove that R is false. So the order of this proof is almost going to be exactly like the order of the last one. So step 4 is list your proof. So let's begin with the not R. I was told that not R is true. If not R is true, then R is false by definition of the negation. Now that I've proven R is false, I can use it in my proof. So let's list the OR. And remember, when you use an OR statement, there's 2 lines of the proof. The first one is you state the OR statement is true and state what that means. If R or not Q is true, then either R or Q must be true by the definition of OR. Now that we've stated that either R or not Q have to be true, let's show which one is true because the other one was false. Well, we proved that R is false, so I can use that. Since R was false, then that means the not Q has to be the true value. And you use the same definition of OR to prove this. Now I've shown that the not Q is true. I want to use the fact that that contrapositive is true, but I wasn't given that as one of my truths. So I've got to prove it. So begin with the implication, P implies Q is true. I was given that was true. Based on that, the contrapositive, not Q implies not P, is true. And that's by definition of the contrapositive. Now that I'm told the contrapositive is true and the hypothesis, the not Q, is true, I can conclude that P is true from the law of detachment. So if not Q implies not P is true, and if not Q is true, then not P must be true by the law of detachment. I was trying to prove not P is true, and I've done that, so step 4 is finished. So the final step in my proof is to end with a complete sentence. I just showed that not P is true. P was I enjoy studying, so not P is I do not enjoy studying. I've just proved this is true, so I can conclude that I do not enjoy studying.